right. Welcome to the night class. I'm Coach Knight. All right. 3-6, critical points in Extrema. Here we are. Critical points. They are any critical points are those points on a graph at which a line drawn tangent to the curve is horizontal or vertical. In other words, it's where they kind of change direction. Okay? So here, this is a critical point. It's also known as, what do we call that? When it's the highest it's ever going to be? It is the vertex, but the vertex maximum, is a what? It's a maximum when it's the highest it's ever going to be. Everybody see that horizontal line we can draw there? Okay. This one, again, it's a vertex, but it's at the bottom, so this is called a what? A minimum. And then you also have these that you may not have been very familiar with before, but you see how we can draw that vertical line right there at P? That is just a point of inflection, okay? It's going one direction, and then it kind of changes directions for a little while, and it continues going in that same direction. Does everybody understand what they are so far, okay? These, maximum points, okay? So I'm talking about this, maximum point right there, okay? If I pick a point on the left and a point on the right of that point, those 2 points are both going to be what? The maximum point. Less or more? Less, okay? They will both be less than the maximum point. If I pick a point on the left or right over here of the minimum point, those 2 points will both be what? More than the minimum point, okay? For your point of inflection, if I pick a point on the right and a point on the left, one of the points will be what? Bigger, and one will be small. Okay? That's how you're going to tell which type of point it is. Everybody good so far? So if you have this, a maximum, point on either side of it are going to be less, okay, than the maximum point. If it's a minimum, the point on either side of it will be more, and if it's a point of inflection, you'll have one that's more and one that's less. Everybody good so far? Awesome. Moving right along. These, you have absolute maximums, absolute minimums. Those are called extremum, okay? Extreme means, you know, out there, right? So it's the most it will ever be. This one, it has an absolute minimum, okay? Right here. There is an absolute minimum. That means, will it ever go below that point? No, okay? It also has a relative minimum, though. This would be considered a relative minimum, okay? It's a minimum relative to the points around it, in other words. It's not absolute, it's just relative. Everybody understanding that? What about this one? Is that an absolute max or a relative max? It's a relative. Does this graph have a absolute maximum? No, because it goes up forever, okay? Is that making sense? This one over here, though, does have. That is an absolute maximum. It's never going to get higher than that. Everybody understanding the difference between absolute and relative? Everybody good? Awesome. Moving right along. This is an example where you have both a relative maximum and a relative minimum. Okay? Can anybody tell me what type of function this would be? Cubic. Very good. Okay? You can tell it's a cubic because it's going in how many directions? 3 directions. It's going up, down, up. The number of directions will tell you what type it is. Okay? You think about a quadratic, it comes down and then goes up. Well, what's the exponent on a quadratic? It's a 2. That makes sense? Okay? If it's just going in one direction, they're a great band, by the way, it'll be a line. Y equals X, because it's only going in one direction. Okay? She's beautiful. Okay, anyway. Example 1. Real easy. Locate the extrema for the graph. Name and classify the extrema of the function. So name and classify just means, is it a relative maximum, relative minimum, absolute minimum, or point of inflection. Okay? So here, how many extrema do we have? 3. One there, and one there. Everybody see them? Okay. -3, -1. What class is that? It is a maximum or minimum. It's a minimum, and is it absolute or relative?
Relative.
It is a relative minimum. Because there's another minimum that's lower than it. Okay? This other minimum, 4, -4, it's considered the what? Absolute minimum.
So we're basically just naming the dots?
Yep. You're basically just naming the dots. Okay? What is 1, 5? It is a relative maximum. Because the arrows show you that this graph continues to go what? Up. And so if it's going higher than your max, it's got to be a relative. Okay? It can't be absolute. Absolute means it doesn't go any higher than that point. That is the peak of your graph. Okay? Everybody good so far? Beautiful. Example 2, you get to use your calculator. So grab your calculator. It says using a graphing calculator to graph f of x equals 5x cubed minus 10x squared minus 20x plus 7, and to determine and classify the extreme. So you need to graph it. Yes, I'm going to try to graph it here. I've already forgotten. Why is that so small? There's got to be a way to make it bigger. But I don't know what it is. View. Show large display. That did not help at all. Hide large display. That's still, I mean, oh well, okay. It is what it is. So, y'all have it in your book. I do not. Okay, 5x cubed minus 10x squared and minus 20x plus 7. And we graph. Okay. So I know for a fact that this, what do I know there are? What types of extrema? If I watched the graph, it went up, okay? It went up, right? And it came back down. And then it went back up, okay? So I know it's doing that. Can I see the extrema? But do I know they're there? Yes, because it had to have come up here to some point, okay, for it to come back down. And then the same thing down here. It went down to some point that I can't see. Now, you can zoom out if you want to, but it's not necessary, okay? Your calculator will do it without you zooming out, okay? You just got to know where these things are. So, I'm going to hit on my calculator, second, let me get off of that, second trace. Let's try that again. Second trace. There we go. All right? And you'll notice number 3 and number 4 says what? Minimum and maximum. Okay? I'm going to find the first one. The first one was a what? Maximum. So I'm going to do the maximum first. Now, follow along with me, okay? I'm going to scroll down to 4, or I can just hit the number 4. It will say on your calculator, left bound, right bound, okay? Your calculator is asking you for help, okay? It wants to know, where am I looking between to find this maximum, okay? So I'm going to move my cursor. Everybody see the cursor blinking, okay? I'm going to move it to the left of, there it is, of where I know the maximum is. I know the maximum somewhere up here. Everybody got me? So I just need it over here somewhere. And once I get it there, I hit enter. And then it will ask me for the right bound. So now I scroll to the right. Now, I keep scrolling until there it is, okay? There it is, right there. It's blinking. All right. I don't want to go so far right that I pass any other extremum. You got me? So don't put it over here, even though it's to the right of it. You're right. It needs to be just to the right. You can't go past your other minimum. Okay? And I hit enter again. It will say guess. I hit enter one more time, and it will give you the maximum.
Does it matter where it is?
It does not matter where, as long as it's to the left and to the right, and it doesn't pass the other extreme. Okay? So my answer here, my maximum, is negative 0.6 repeating. Okay? Or negative 0.67 if you want to round, or you can use the little repeating bar. And then my y is 14.4. Is that 0.7 or 8.7? Is it 0? So 14.41. That would be my maximum. And then what type of maximum is it? Absolute or relative? Yeah, what kind of maximum is that? It is a relative maximum because it's going to keep going up on the right there. Everybody see that? Okay. How do I get the minimum? I go through that whole thing again. Second trace. This time I'm going to do number 3. And I have to do left bound, right bound thing again. But now I'm doing it to the left of my minimum down here. Again, I don't know exactly where it is. I just know over here somewhere is to the left of it. Is that making sense? Okay. So I'm going to scroll. If you ever lose your cursor, okay, if you ever lose it, you can't find it, it's like way up here, way down here. This always tells you where it is. Right now it's at 0 what? 7. Okay. So if I can keep going, now technically could I use any of these points as my left? Yes, because I'm not so far left that I pass the other one. Everybody with me? So that works. I hit enter, then I scroll to the right. I'm all the way down at negative 30, so now it's coming back. Here it comes. Boom, there it is. All right. Hit enter again. Hit enter one more time. Your relative minimum is, if it's 1.99999, just put 2. Okay. It's 2 and negative what? 33. All right.
I get mine to like here.
Can't get it to move.
Like it does, but it only goes like here or here.
No, you left or right moves it up or down. Because you're changing the x. Is that making sense? Yeah. You're never going to move it up using the up and down arrow. You have to move it left and right. Because you're changing the x. You're not changing the y. You got me?
Oh, I see now.
Okay. Any questions on those? Everybody good? Okay. Let's try one more again. Let me get out of that.
How much homework? Oh, we got 13 to 33
Is this the AC?
All right, last example here. Example 3. It says this function, 2x to the 5th minus 5x to the 4th minus 10x to the 3rd, has critical points at x equals -1, x equals 0, and x equals 3. Determine whether each of these critical points is the location of a maximum, a minimum, or a point of inflection. Okay? So they tell you the critical points. Now understand, they want you to do this without graphing it. I understand you could graph it and tell me like real quick, okay? But they want you to do it without graphing it. So we're going to do it algebraically. So we're going to make a table. Okay? So their table, I don't really like their tables because their tables always confuse me. All right, so the first point I'm using is what? -1. So I'm just come over here and I'm going to make a table. X, Y. All right? I'm going to put -1 right here in the middle, and I'm going to plug it in. What do I get when I plug in -1? I need your help there because y'all got the calculators. 2 times -1 to the 5th minus 5 times -1 to the 4th minus 10 times -1 to the 3rd. What does that give you? No pressure.
I got 3.
3. I think that's what I got in my head too. Okay? Now remember what I told you a minute ago, okay? If it's going to be a maximum, that means the points on either side of it will be what? 3. Less or more. If it's a maximum, it'll be less. If it's a minimum, the points on either side of it will be what? More. And if it's a point of inflection, one will be more, one will be less. Okay? So we're going to pick numbers. And again, don't pick numbers way far away. And 1 is way far away. So I'm going to pick, like they did, -1. I'm going to put -0.9 would be just to the left, right? Okay? What's just to the right? -1.1. And I actually said those backwards. Okay? -1.1 would actually be to the left. And -0.9 is actually to the right. Okay? So plug -0.9 in. And what do you get? It will be a decimal. .8? 2.829? Okay. Do y'all see their table here? Okay. So here's my original point. Here's one to the left, here's one to the right. So I'm just showing you how you can read their table. So what did they get when they plugged in -1.1? They got what? 2.769, right? Both those numbers are what? Bigger or smaller than 3? They're both smaller, so that means this point must be a maximum. Okay? Relative maximum. That makes sense? Okay? And then they do it with all 3 of them. So 0, okay? If you're doing 0 right here, you're going to do, to the left would be -0.1, to the right would be +0.1. Well, at 0, the one on the left was 0.009. Is that more than 0 or less than 0? That's more, okay? So this is higher. The one on the right is what? Less. That's not a -0. That's a -0.01. Okay? So, since one's higher and one's lower, it's a what? It's a point of inflection. Or if you just say inflection point, that works too. Okay? And then at 3, a little to the left would be 2.9. A little to the right is 3.1. To the left, we get -187. To the right, we get -187. And in the middle, it was -189. Well, both of those, I know they're negatives, but they're actually what? Bigger, right, than -189. So it is a minimum. Any questions? All right. Make sure you do your, what is that, like 10 problems tonight?
11.
Hope this video helped, and y'all have a blessed afternoon and stay above the line, as always.